device which can be deployed by any business center, thereby bypassing typical network security control and processes. All these network connected IoT devices may consist of printers, cameras, sensors, lightning application, infusion pumps, handheld scanners. Many things are there. So the thing here is like, if there is a central server from which multiple IoT devices are connected in any organization, and on the same central devices which where it is kept in any organization, there are multiple appliances which are also connected through a network. So if any attacker get chance to access or to attack on to get the successful attack on any of these device, then there is a high probability that there may be intrusion in the entire complex infrastructure of internet of things. So, IoT security can be understood as a cyber security strategy and a protection mechanism that safeguard against the possibility of cyber attacks, which specifically target physical IoT devices that are connected to the network. And without robust security, any IoT connected device is vulnerable to breach, compromise, and control by a bad actor to ultimately infiltrate, steal user data, and bring down systems. So let us assume that there is a router through which we access internet, means some wired connection is bring into the router, and and from there we just make it a wireless through a router, and we use the internet in our houses. Now suppose if a attacker somehow got access to that router, because whenever a router is installed in our home or anywhere, there is a some credentials are associated with that router. And sometimes it has been seen, and also it has been researched that the credentials, that is user ID and the password associated with that router, is not always very good. Sometimes it is a general user ID password. Sometimes user change their password, but they set their password very weak type of password. So any attacker can easily guess it, or easily get the access of that router. So once any attacker gets the access of that router, that then he can do anything with the entire network and the devices which are connected to these networks, or which are connected to with these routers. Okay, so this is about how, this was about a use case how any attacker can get access through any router inside any industry, inside any home, or anywhere where a small router is being used for the networking system. And also with that networking system, there may be multiple IoT devices which are connected, which are continuously working and transferring data. So next we will see a use case that if infected uh, any malware is inserted into any IoT devices, then it may create distributed denial of service attack on the network. So suppose let first we will get to know about the denial of service attack. Like if any attacker is continuously sending a false request to a server in a bunch, means we are sending request to any server continuously, that is known as a flooded request. So when a server receives a flooded request from the some garbage kind of request, mean the request is not genuine, request is not authentic, request is not a for very good purpose, instead it is only done to make the system down. So if a server is getting a flooded request, then what would happen? The server will be busy in handling that request, and once a certain threshold will be reached, the server will be get down. Means it will stop giving the services further. So in that scenario, if any genuine user come to get the service from that server, it will not be easily get serviced by that server, and in this case the genuine customer or a genuine user will not get service. So this entire scenario is known as a denial of service, where attacker sends a flutter request to a servers to make its services down. So now when we talk about the distributed denial of services, means if there are multiple IoT devices nodes, and if a attacker is successfully able to insert any malware or any virus inside these IoT devices, then it may happen that these IoT devices may send the garbage request to its servers, because these IoT devices are continuously sending data from them to a server. But now after getting infected, they will start sending some garbage kind of request to that server, and in this case the entire infrastructure will get down. So this is the major thing in the IoT security which is very necessary to be handled. Now there are multiple IoT security challenges associated here, like inventory, thread, data volume, ownership, diversity, and operations. So we will see all these one by one. If we talk about the inventory, see in a internet of thing, in the current digital era, there are millions of IoT devices which are installed for a particular set of tasks. So if there is an IoT devices which is working fine and collecting data and performing some set of applications in any environment, but when it is not very much known that what kind of data is it is sending, what kind of encryption or what kind of security strategies is defined with that IoT devices to secure the request or to secure the data being sent by these IoT devices to a server. So next is the threats, in which lack of well embedded security into IoT devices operating system that are hard or impossible to patch. So in a IoT devices which consist of very less resource or are not very much containing the good resources or good computational power or good storing capacity. So in this scenario it become very hard to install some set or and some technologies related to security which could be able to secure the entire IoT devices along with the data which is being sent by these IoT devices, or along with the request which is being sent or received by these IoT devices. Next is data volume. Since we know that the IoT devices, the initial work of this IoT devices is to generate data. So having this millions of IoT devices, the data which is generated by these IoT devices are very much. So having a large amount of data generation from these IoT devices, it is also very difficult to manage all the data, and in between this, the hacker gets the opportunity to make some kind of attacks on these data, so that the attacker can get access to the entire system. Similarly, about the ownership, if for a infrastructure containing IoT devices, if there are some set of persons who are responsible for managing the entire infrastructure, and if there is some person with having some malicious intent and get unauthorized access to some system, or try means the a person can behave as an insider attack for this infrastructure, then in that case also the system can be compromised. So there should be some kind of mitigation strategy. There should be some kind of level wise security where authorized person, only the authorized person can get the access to a certain level, so that we can identify the malicious attacker behind this. So similarly, there are different type of IoT devices in the world, and there are different kind of security strategies to secure a different kind of attacks being performed on such IoT devices or the server. So having such kind of diversity in the devices, diversity in the data, it is also very difficult to define multiple security strategies to overcome the issues happening in corresponding to the security aspects of internet of thing. So also if we talk about the operations, to perform the operations which are associated with the some IoT devices, when these IoT devices are integrated into some systems, and we see the entire system along with these IoT devices. See, when the security strategy for a separate system is different, but when we integrate some additional system into some predefined system, then the security strategy may changes according to the newer integration to the that system. So the operations which is being performed through to that system become differ in that case, and accordingly the new security strategies are defined when some IoT devices are integrated into a newer system. Now if we see the we can see here a image where a attacker is shown, where a target server is shown, and the entire IoT network is shown, where each and every devices are interconnected to each other, and also they are connected with the server. So whenever a attacker gets success to infect any of the devices, it may send the server to it may send a false request to this target server, and as the attacker gets success in targeting the server, in getting the access to that server, or making the server down, or making that server breached, the entire IoT network will be compromised very easily. So this is the thing about this IoT security, why it is very much necessary to have some security measures for the Internet of Things and the associated networks. So this some statistics is given here with the share of security issues for the uh, healthcare sector, and other nodes like a medical imaging system, patient monitoring system, medical gateway, energy management devices, security cameras, printers, consumer electronics, phones. So these statistics represent how much such devices have the share for the security issue. Means the 33% in the entire security system, the security cameras shares the 33% of it, where there is a chance to get hacked or to get attacked by some malicious attackers. So many IoT devices are very small, resource content, and often lack a robust security feature. They may have default username and password, outdated firmware. So suppose that we have purchased some IoT devices, or for a simple, for a sake of simplicity, we may take some routers in which some firmware is deployed. Now with the introduction of some newer technology, some newer security protocols or some newer security methods, the firmware which is inbuilt in that router should be upgraded. But once it is installed anywhere, we do not very much care about that. And whenever some new kind of attacks came into the market, it get very easy to access that router, and the entire system gets compromised. So this is what we have seen now. Now we will see some best practices for the IoT security. Like, firstly, we have to understand about the our IoT assets. Then there is a need to assess the IoT risk. Means we have to first check out the IoT devices which we are using, and after that we have to get assess that what kind of risks are associated with that IoT devices, how much level this can be compromised, and then accordingly we have to apply some risk reduction policies means we have to apply some security measures into it to deal with the risk which is associated with that IoT devices. Then we have to apply some security measures to prevent known threats which is in general known for all the IoT devices. So we also apply some preventive measures in that IoT devices in general, for which the IoT devices can get hacked by some attackers. Also, at the last, the fifth stage, if any new attacks came into the effect which is not known very earlier, then that is detected and is responded as an unknown threat. And after that, the new mitigation strategy or the new measure is made to deal with that unknown threat. And in the later stage, it will get in the list of the known threat, and we try to install, we try to configure, we try to inbuild the security measure for that threat in general in all those IoT devices. And this cycle goes on and on. And the main important aspect behind in this cycle is that we have to check for all kind of threats which can be occur with that IoT devices, along with their security measures. If the threats are known, then that is okay, the security measure will be integrated in the system. But if some new kind of threats come into the picture, then the correspondingly the security measures are designed and is listed in the list of the security attacks and their preventive measures.
Okay, Mr. Harshit. Uh,
Okay.
okay, just now there is a chat from Mr. Julius. He is asking to you.
Uh, uh,
Let me read for you. Why imaging medical data has the highest security issue? Is it because of the existence or value of its data, or the common security system applications on IoT medical related device or system nowadays? That's the questions from Mr. Julius, Mr. Harshit.
okay. Okay. So let me. Okay. Okay. Got your point. So for this the for this question, I am just going to start these slides, and you may get the answer in this slide. And also at the last, if it will not still clear to you, then I will answer to you. Okay, Julius. Okay, so now we will start with the privacy related to IoT data. So the IoT data privacy is a very critical concern given the widespread use of connected devices that collects and transmit data. See what happens with the IoT devices. It sends the data and transfer to a central server. Now, after sensing the data, what it does, it stores the sensed data and then transfer to a server. So this transfer of data to a server is the important factor here. Like if we talk about some data, some critical data which nobody wants to share. Suppose uh, we want to make some models, like a model for healthcare which could predict some disease like a cancer prediction. If we have the picture of picture of the area which is captured to detect if a person is cancerous or not. Similarly, if we have the picture of ECG data or any data related to heart disease, by analyzing those pictures or by analyzing those image data, if we could be able to make some machine learning model, and that model will be able to predict something, that if a person is cancerous or not, if a person is going to be having a heart attack or not heart attack. So these kind of things can be done through a machine learning. And what happens in a traditional machine learning approach, that to train a model for some set of application, for some set of healthcare prediction, it is very much necessary that it should be trained on a large amount of data. It is to be trained with the large amount of data, so that the performance of a machine learning model would be would give some good results or give some good prediction. But here there is a very critical issue related to a data, that is data privacy. Like nobody wants to share their data. I do not want to share my medical data to anybody. I do not want to share my personal data to anybody. Even I do not want to share my financial data to anybody. So if no one will share their data to any company which is going to make some kind of machine learning model to make predictions on any application, a specific application domain, then how we will train the model? Because the actual training will be done by the actual data, and to make the entire system work properly, it is very necessary that the model should be trained from the real data. So to mitigate that issue, to resolve this issue, some new methods, some new technology came into effect, that is known as federated learning. The concept is known as federated learning, where the machine learning model is trained without sharing any user data. That is a very important thing here. Like what happens in a traditional machine learning, an artificial intelligence model is the data is given to these model, and once the model is trained, it gives some kind of predicted output. But here the data which is shown here is collected from each and every person. Means if we talk about the machine learning model of healthcare, the data of every patient will be collected here from all the hospitals of the region, so or all the hospitals of the country or all the hospitals of the world, we can say here. So in here, in this manner, there is a central repository where all data of the every person will be collected from the all the hospitals, and once the data will be collected, that will be used for the further training of the machine learning model. But here in federated learning, what happens, the data is not collected from any hospitals. Even without collecting those data, we are able to train our machine learning models. We are able to our machine learning models to make a good prediction or accurate prediction. So how it happens here, we will get to know in the in this area of this federated learning, which is a privacy preserving machine learning. So this, the concept of this federated learning was given by the Google in 2016, and the best example of this federated learning we can see in our mobile phones, where we use keyboard like given by a Google, that is known as a Gboard, where once we type anything, it starts giving us a suggestion. So sometime we, if we want to write a happy new year in the time of a new year, once we write happy, it automatically gives us the suggestion new year. Why? Because it is being trained from the data of all the users. But here, how it is training its data without sharing the user data is like, it works in a distributed approach. Suppose there is a client 1 containing data, like having data source 1, and this data is corresponding to this client. Similarly, there is a client 2 have, which is known as a data source 2, containing his data this. Similarly another client containing this data. Now what would happen? A model will be trained near to the data. So a initial model will be trained from the private data of this client locally. Means this data is not going to any server. This data is not going to any repository for for the training of a model. Instead, this data is only used for the model which resides at the local client. Similarly, for this model, that will be trained by the data of this client 2 at local to this client. Similarly this. So what is happening here? A local model is being trained at every client. So here we can assume a client as a hospital. Suppose this is hospital 1, and this is the entire cancer data of all the patient of that hospital, and this hospital is making its local model here from the data collected by all the patient, and now this model is trained. This is hospital 2, this is hospital 3, and this is hospital n. Now after training these models, the model updates of all these model will be shared with the central server. So we will extract out the model update, not the data. The This model update is obtained after the training of a model from the data. So now this model update, the model update of this model update of this model, and similarly model update of nth client will be shared with the central server, where there will be the global aggregation of the all the model updates. And then after the aggregation of all the model updates, it will again send to all the models. And once the model will receive the aggregated weights, it will update itself. So in this way, all the local model, all the hospitals will have a model which is now trained with all the data of hospitals. Means now this model is now trained with this data. Similarly, this model is now trained with this data. So in this way, without sharing the data of any entity, we are able to make training of a model, and we can get what we want to do. If we want to make some model for the prediction of consumer purchasing behavior, if we want to make a model for the prediction of risk associated with some insurance company. Similarly, if we want to make predictions related to the health condition of any patient, we can make that model without sharing any data to any central repository, to any server. So now here, if we see the IoT, Internet of Things, which is continuously generating data, then what may happen, that it sends the data to a central server for the further processing. Now sending this data to from the IoT device to central server is a very prone to attack by the attackers, and attackers may use these data manipulated. We use these data to check the status of the IoT device, to check the environment where this IoT device is integrated. So now here we have vanished the need to share data, and without sharing data, we are now able to process the data sensed by these IoT devices. So this is the very important development in the field of artificial intelligence, where the privacy is now being preserved, and we can be able to make some machine learning models for the uh, for some set of applications. So here in federated learning, there is some average algorithms which works in a manner which I have told you, like the local training of a model is happen, and once the local training is completed, it is shared with the central server where the global aggregation is performed. So there are multiple things associated with this federated learning system. There are different kind of federated learning system, that is horizontal, FL, vertical federated learning, hybrid. Different machine learning models are applicable here. Different communication architectures are given. So this is the broader overview of this federated learning. So if you want to know more about this federated learning, you can get each and every detail about this federated learning on some research papers based on federated learning. If you will need, I will share with you. So if we see this federated learning, it is applicable to everywhere, like in the smart city, in the uh, smart manufacturing. So there are in the with the industrial IoT. So this federated learning is very much useful in all those places where internet of thing is being used for some specific set of applications. And by making the use of this federated learning, we can ensure the privacy of the data which is being shared from the devices to a central server. And we can also reduce the privacy concern related to the internet of things. So this was all about the security and privacy of internet of thing. As we have also some time constraints, so I have just given the overview about all of these, because next we will see some uh, uh, machine learning modeling about Python code about that, and we have to also make some kind of assessments. So now I am just wrapping up this session for this IoT security and privacy. Now you can ask the questions based on this, and then we will go for the programming sections. There are some tools given which we can use for the to implement the federated learning. You can also make use of federated learning in your IoT devices for making your IoT devices having the ability to automate it, to make predictions, to integrate machine learning properties into it. Okay, so if anybody wants to ask question, I'm opening the session here only for maybe 2 to 3 minutes. Then we have to go to for the next work for the coding aspect of this session.
Yeah, maybe any question from all the audience? I think
So,
there's, yeah.
Julius, is it clear? So, let me just clarify what you have asked in the chat, that why imaging medical data has highest security. See, imaging medical data consists of the entire picture of the human parts, or if we take, suppose that we have some ultrasound, we have some X-ray, we have some ECG, or so many kind of tests are there which are converted into some image format. And these images consist of many informations which can be used to get the entire functionality or more detailed information about the patient. So that is why the imaging medical data have the highest security issue. If we give only one parameter to anybody, like the person is having temperature some x degree, then that is okay. But if we give some picture of entire abdomen, then what would happen, we may infer multiple information from that pictures. So that is why it has the highest security issue. So sharing of such kind of medical documents or medical tests in which are in the form of image, it is very critical. So that's why we use the concept of federated learning to make analysis on these image data set of the healthcare. So okay, I think now we should move to next part. So let me share. Okay, so this is a very basic code I am going to show you. So this is regarding the prediction of weather. So here you are using some sensors and you are integrating with some computational devices, then you can use this concept to make some projects to do some research in that particular area. So suppose we have installed some weather stations or some sensors at any place which is continuously sensing the environmental temperature in wind direction or wind speed, precipitation. So in this scenario, if we want to predict whether there will be rain or not, if tomorrow will be rain or not, we have to predict this. Our aim is to predict the rain condition based on the temperature, precipitation, and wind data. Now, how we will create a machine learning model which would be able to predict this scenario? So for that, what we will do, firstly, we will train a machine learning model with a lot of data having parameters, precipitation, temperature, and wind. And also we will give the class of rain that is given here in the form of weather, that whether there was a rain or not. So once the model will be trained on the data set, on the data given to it, and after the training, we will give it to some input, and it will give us that whether there will be rain or not rain. So we are not working on the front end part of this machine learning. Instead, we are dealing with how we are training a model to perform such specific task. So for that, what we will import some libraries here, some models here first, and then, so firstly, like these are the some libraries given, some pandas, numpy, we will just import it. After this, we will load a data set. We can see the data set. Let me check.
Harshit, could
Yes,
you please help us? Just maybe you can zoom bigger, little bit bigger for the could maybe.
little bit
Yeah,
bigger. Okay,
yeah.
okay, let me
Thank you.
see.
Yeah, thank you.
Now it is okay.
It's okay. It's okay. Yeah, thank you.
Okay, that's pretty cool. So here you can see the data precipitation. Some values for this precipitation is given. Maximum temperature, minimum temperature is given for some specific time. Similarly, wind speed is given here, and weather is here, like whether there was a rain or not. So it is showing only five entries because we have used data dot head. If we will see the actual data set, there is 1 and 0, 1 0 kind of things are there. 1 means there is a rain, and 0 means there is not rain. So this data set will be used for the training of the model. Now first we are reading the data which we are using, that is settled weather.csv. This data set is in the form of csv format. Then we will use some pre-processing on that data, where we will do the pre-processing for the missing values or some for NaN values, means we before using the data set for the training of a model, the data set is pre-processed to remove the garbage values, to check for if there is any missing values or not. So there are different techniques for such kind of pre-processing, but we have here only used some simple method for the pre-processing. Now after that, we are taking two things here. First is feature and next is target. So feature means on what basis we have to predict, and target means what we have to predict. So here the prediction of weather means prediction of whether there will be rain or not is now based on precipitation, this temperature max, temperature minimum, and wind. Now based on these four parameters, the model will decide if there will be rain or not. So for this we have taken features and target here. Now what we will do, we will do the splitting of data. Splitting of data is done. Suppose that we have 1000 record in a data set, just like here it is showing, suppose that 5. Suppose we have 1000 records. Now we want to train our model with some of these record, and we will test our trained model also with some of these record. So for that we have taken test size zero point 0.2. 0.2 means we have taken the test size of 20%. Means for the 80% of the data we will train our model, and for the rest 20% of the data we will test our model. So that is why test size is given here is zero point 0.2. So data will be now splitted here in the training set and the testing set. For the training set, the model will be trained, and after the training, the testing set will be used to test whether the the model is performing good or not, whether the prediction made by the model is accurate or not, very much accurate, and what is the difference between the actual value and the predicted value. So that's why we separate the test data, so that we can check our trained model in the later stages. Now we have import libraries, we have import data, we have splitted data, we have finalized the features of features and target. Now we have, it is just showing the some data, five data of our entire data set, that what kind of parameter it consists of, that is precipitation, maximum temperature, minimum temperature, wind, and weather status refers to the rain condition. Now we have taken a model here, that is a support vector machine we have taken here for the training of the model. See, this is the very important thing in the area of artificial intelligence, or we can say in the area of machine learning, that which model we are using for the training purpose. Means if we are using some data of some text data, then what kind of model will be used, what kind of classes are there in the data set, this is also the basis of selecting the model. If the model consists of some image data, then the machine learning model will be changed. So this is a very big concept of this is a very big area. So to get the details about the different kinds of available models in the machine learning, we have to go through some tutorials, some papers where we will get about the what kind of models are there, in which scenario they are used. So here for the simplicity, we have taken the support vector machine, which is a binary classifier model. So support vector machine is also a kind of machine learning model which classify the things, means it performs the classification based on the features. If we have given some features, it will tell us what would be the target. So classification is done by this support vector machine, and in that the binary classification is the important one. Means in our data set, if there are two kind of output variable or two kind of target variable, or we can say that two type of classes. So two type belongs to that. If there is a rain, that it is, if there is rain, if there is not rain. So for one type there is rain, and for the another type there is not rain. So we can we have the two classes only here. We have two target variables only here. We have only two output. So in that scenario, support vector machine is supposed to be a good performing model. So that's why we have taken here a support vector machine. Now in this model we have first selected this model, and now in this model we have fitted all these training data. X train and Y train is fit with this model. Now once we write this line, it means now model is associated with the data set for which it is to be trained, and also it starts training of the model. Now what would happen, it will check the prediction. So prediction, the Y prediction, it shows how it will check how model is performing, how much accurate our model is performing. And to make prediction and to check for the prediction, test data is used, which we have earlier splitted into training set and testing set. Now testing set will be used to check for the performance of the model. Now once the model is trained, model is checked, we will check what is the accuracy or what is the performance of our model. So because whenever we train our model, it is very necessary to check the performance of our model. So in this scenario, I think it is we have got this. Okay, so let me see the. Okay. Okay, now the data set is load. So here see, we have taken accuracy to check the performance of the model. So accuracy is a matrix. It is a performance matrix which tells us how much our model is accurate. What is the accuracy of our model? Means 80% accuracy means it is giving the 80% correct result while the testing of the model. So our in the field of machine learning, and when we go for the research in the field of machine learning, our main aim is to enhance the performance of machine learning model. So currently it is giving 0.80, means 80% of the performance. But now we will dig into it. We will go some more concepts of the machine learning. We may change some parameters. We may go for some newer algorithms for the matter, for the model, so that we can be able to enhance this accuracy to 90% or 99% or maybe 100%. So if we achieve the accuracy of 100%, it refers that our model is predicting very accurately. If means it has never predicted anything wrong. If it has predicted that there will be rain, then there must be rain. If it has predicted that there will not be rain, there must not be rain. So that is the power of 100% accuracy of the model. So now if suppose you are using any temperature sensor or any humidity sensor, so you may collect the data of these sensors and make some target values, synthetic target values for that. And on the basis of these created data sets, you can train your machine learning models, and make you can make also some projects, some research oriented works based on the combination of IoT devices, its collected data, and this machine learning Python scenario. So this is the very basic one which I could give in this short period of time. If you have any questions regarding that, you can ask now, and then we will go for further phase of this session. No further questions, I think.
Maybe not yet, Harshit, so you can continue.
Okay. So I think Yosia has asked some question. When we continuously use IoT devices, the sensors will inevitably experience a decrease in value. How can we ensure that the value displayed by the sensors are accurate at all the time? So see, this can be done through the concept of machine learning, where we use the concept of some anomaly detection. Means if a sensor is continuously sensing some data and transferring it to it, but there are some instances when the data sensed by these sensors are not very much in the are we can say that the garbage kind of value, or are very different from the general values which is to be predicted by these sensors. So this can be done by the concept of anomaly detection in machine learning, where what we do, we just try to make a machine learning model and train it with the data set of the IoT devices. And this machine learning model continuously sends the data received from these IoT devices, and when it feels like that the data now which is coming from the IoT devices is not the proper, or it's some kind of garbage value, or is not very much appropriate, it gives us the some kind of notification, some kind of alarm, or some kind anything could be done. So this can be done through the concept of the machine learning. And also, if there are multiple things related to IoT devices, like in the while when the machine learning works, when the IoT devices works continuously, for a day, for a month, or for a year, it there may be the chances like some kind of storage issues, some kind of CPU utilization issue. So for that, the software rejuvenation is done. Means we just restart the entire system so that the IoT device get refreshed and starts working properly. So there is a concept of software rejuvenation which should be go through to get more about the data related to these IoT devices. Okay, so now I will share a Google form with you, which consists of only one question. You have to read this question, and you have to write the answers within 200 words. So now it is 5:05. The time limit for this assessment is 15 minutes. I just send the link on the chat box. Please see the chat box.
Yeah, it's already ready. Harshit.
Okay, here you go. I have sent the form on this chat box. Please access it. Let me know if you face any issue, and fill the form by writing the appropriate answer. And also, please do not use any AI tool like ChatGPT. Just write whatever you know, what you have learned in the entire of these sessions. Okay. So this is not a kind of very important kind of assessment, but it is only for that, like what you have what you have learned so far in this entire session. So again, we will meet after 15 minutes. Please fill this form.